So let's start by reviewing what we learned yesterday for the midpoint. Basically, you can find it by taking the average of the x-coordinates of the two endpoints and also the y-coordinates of the two endpoints. And that's the midpoint formula. So today we'll learn another formula called the section formula. And this is more interesting because I want to divide a line into several parts. So let's say this is 0, this is 12, and I want to find a point where the ratio is 1 to 3. So if I call this point P, what is the value of P? Just by any method. If the ratio of AP to PB is 1 to 3, what is the value of P? 3 or 4? 3. Why?
No, because that means there's 4 parts to it. One get base on, so that's like 1K and 2K. So 1K after
So what your classmate mentions is that according to the 1 to 3 ratio, she sees 4 portions. And that's the first important point about section formula. Whenever we need to use section formula, we can find the value by dividing into the correct number of portions. And I'll now give you the formula. The formula looks like this. The x-coordinates of P, if I call this ratio R to S, it would be S times XA, and no need to copy because we are going to get that very soon. I just want to illustrate that before we actually drill into the formula. I'll show you how to deal with that, but I just want to show you, okay, you are dividing into 4 portions. You're dividing in 4 portions. And then the 3 and 1 are each being multiplied to 1n, the value at one of the ends. So 3 times 0, 1 times 12. And that gives you the final answer of 3. So in your book, it is annotated this way. 1 is multiplied to 12, whereas 3 is multiplied to 0. And you may ask, why? First of all, why 1 plus 3? As you mentioned, 4 portions. So taking the average as if this is from 4 portions. And P is nearer to which point? P is nearer to A. You agree, right? If P is nearer to A, the effect of A, or the inference of A, is larger. The 1 to 3 ratio means that B is so far away that its inference on the coordinates of P is smaller. So we multiply to the coordinates of A by 3 and B only by 1, indicating that A has a larger effect on the final coordinates of P. Yes, the ratio is 1 to 3. So you would, without learning this chapter, you would think, okay, 1 times A, 3 times B, but actually it's the other way around. 1 times B, 3 times A. And this can be attributed to A having a greater effect on the coordinates of P. Let's say 1 to 3 I change it to 1 to 300. If it is 1 to 300, basically P is at A, more or less at A. So it means that A should have a much, much greater effect and B is not too significant. So the greater number is multiplied to the side with a greater effect. This is one way to interpret that because I always consider this as a weighted average. 知唔知咩叫 weighted average 啊？ Weighted average is like your test score is multiplied by 1, but your exam score is multiplied by 3. Things like that. So with a weighted average, A should take a greater weight. But even if you don't entirely understand the reason why it works, as long as you know how it works, you can still work on the formula easily. So in our formula, if P divides the segment, joining this in the ratio R to S, please add a word internally. So it means P is within AB. Then we have the section formula, which sets P, the x coordinate is the average of the xy coordinates, but A is multiplied to S, whereas B is multiplied to R. So these two arrows help you to remember which ratio to multiply to which point coordinate. So, section formula, look at the following example. If we look at the x coordinates, then at A, the ratio is basically 0 to 5 and is fully influenced by A. Further away from A, the influence of A is still greater. This is a 1 to 4 ratio, so 4 multiplied to A, 1 multiplied to B, and etc., etc. You may consider this diagram as your basis for weighted mean of section formula. So it's just like weighted mean means weighted average, okay? If you haven't learned this before, we'll learn in book 3, chapter 6. So basically, the word still mean average, and that's book 3, chapter 6. We'll teach next week, hopefully. Example 27 though, if we have AP to PB 1 to 3, and I want to find the coordinates of P, you just apply the formula. I would apply the formula carefully by write the ratio here, and then draw the arrows to help yourself remember which one is multiplied to which. Especially when you start working on this, you will be relatively unfamiliar, okay? The order of the denominator does not matter. You can say 1 plus 3 or 3 plus 1. But in the numerator, above the fraction bar, make sure you multiply 3 to the coordinates of A and 1 to the coordinates of B, because, again, A has a greater influence on the coordinates of P. And similarly, minus 7, 7. So taking the average gives you that P has the x coordinate of 1 and y coordinate of minus 7 over 2 or minus 3.5. So you may think, Mr. why is it not an integer? In coordinate geometry, it's typical for you to encounter like small fractions like this.
What, like, so it wouldn't be any like really crazy decimals, like
It can be, but seldom. Okay, one more comment before we move on. Let's take a look at the x coordinates of A, P, and B. We know XA is minus 2, xb is 10, agree? And then x of p, we have found out to be 1. So my question is, apart from the formula, can you use another way to very quickly verify that this is a 1-to-3 ratio? So we can see that this is 3 and 9. 3 and 9. Well, 10 minus 1 is 9. 1 minus 2 is 3. So you can definitely convert it quickly to 1-to-3, and you have the peace of mind, you know this is definitely a 1-to-3 ratio. Just by observation and very quickly calculations of the differences. Okay? So yeah, remember in this chapter, the good point for you is that you get plenty of practices. So work on these 2 practices. For practice 27, it's probably easiest to let the coordinates of B be in terms of some sort of unknowns, x, y, a, b, h, k, whatever you want. And then you know the ratio is 1-to-2, so you draw the arrows this way. Your coordinates of P, the x-coordinate would be formed by 2 times of the x-coordinate of A plus 1 time the x-coordinate of B. So divided by 1 plus 2, you can see this is sort of like a weighted average. And then you will work out A is what? Hang on. 3. A is positive 3, okay? Similarly, for the y-coordinate, 1 equals 2 times 1 plus 1 times b divided by 1 plus 2. This is even more weird because I should get 2 instead. Still weird. B equals, no. Oh, yeah, of course. 1 plus 2 is 3. So anyway, B, the full coordinates are 3, 4. And in the second part, so note that 3 equal parts means that AP to PB is 2-to-1. Meaning that you can apply the section formula directly. The coordinates of P are 1 times of the coordinates of A, x coordinate of A, plus 2 times x coordinates of B, 1 time the y coordinates of A plus 2 times the y coordinates of B, and taking the average gives you 3, 5. And then to find Q, of course, you can reapply the section formula, or if you trust your calculations above, you can just apply the midpoint formula, which is, well, slightly easier. As your classmate mentioned, the section formula will look slightly complicated. All right? So if you are good so far with this, let's look at example 29. Many of you will probably find the value of k first, but I want you to start by following this directly. So to find AP to PB, well, you have nothing to rely on. So just as an introduction, something I'm not sure whether you know, if 4C equals 5D, then what is C to D? 要唔要轉? If E over 6 equals F over 7. Then E to F is?
6 over 6 is 6 over 7.
Yep. So if you know both of these, then I will use the method of letting AP to PB be R to S so that you can easily group terms. Okay, if you let AP to PB be R to S, since the X coordinates are fully known, it would be slightly easier for you to work on the X coordinates directly. And the X coordinate is the average, which means 2S plus 8R, because R to S multiplied this way. So 2S plus 8R divided by R to S would be 4. So if you simplify this expression, you get 4R equals 2S. So R to S is 2 to 4, which is 1 to 2. Bear in mind, we started with assuming that AP to PB is R to S, so you get the ratio is 1 to 2. And just as normally for ratio, if possible, we need to give integer ratios and also simplest. So I don't accept 2 to 4 if 1 to 2 is an available option, because this is just a fraction.
Wait, I just don't understand why can't we just use like the ratio of like you calculate?
Yes, you may. I'm going to mention that. Okay, so some of you may see that what happens here is that we have a pair of similar triangles. Or at least, if the top ratio is R to S, then this ratio is still R to S. The horizontal length ratio, do you agree? So, if we do ask you about section formula, what you may do is to directly, as your classmate mentioned, calculate the length. And yeah, because the horizontal ratio is obviously the ratio of the inclined line, so of the slant line, so go ahead and do this. And in part B, they ask you to use the result of A to find K, so you must apply AP to PB is 1 to 2. And to find K, it means you use the section formula on the Y coordinates. And that gives you K equals 6.
Can I not add the AP to PB?
Yeah, you may. You mean skipping this step, right?
Yeah.
Okay. And then, just getting back to a few lessons earlier, if I don't find the ratio, can I find K?
Yeah, I think so.
How?
Slope the slope. Yeah, slope.
Slope, okay. So yes, you just say slope AP equals slope AB, okay? Right. Okay, your turn to work on 2 more questions, and then we'll have finished this, and then we'll move on to some more exciting questions related to centers. Practice 29. cut the y-axis as r, so indeed you may let the coordinates of r be 0, r. At y-axis is the x-coordinate, which is 0. And be very careful what they ask for. It's PR to RQ. So if you let the, maybe I'll avoid R so that, because I see plenty of you using R in your steps. So you may let this ratio be R to S if you let it this way. PR to RQ is your general R to S. Then make sure the R to S is written in the correct way round, such that you get 4S plus 2R, minus 2R over R plus S is 0. Be very careful when you multiply 0 by anything, you still get 0. So R to S is actually 2 to 1. Our PR to RQ is 2 to 1. Plenty of you actually draw the correct 2 to 1, but you answered as 1 to 2 because you mistaken the relative positions of P and Q. 答案係2比1，2比1。咁如果你計1比2就其實通常係你調轉咗 PQ 嘅位啫。So once again, the alternative method, PR to RQ would be PR takes the x coordinates, so 0, 4 minus 0. RQ takes the x coordinate distance, the horizontal distance is 0 to 4 to 2. So the horizontal distance ratio is also the length ratio of the two segments. So anyway, R equals 0, 2. So for the second part, find the coordinates of A and P. If you let A equals AB, then by applying the x coordinate and the y coordinate of Q respectively, you get A equals minus 1, B equals 4, so that the coordinates of A are minus 1, 4. And then the coordinates of P is the midpoint, so taking the average of minus 1 and minus 7, taking the average of 4 and minus 2 gives P is minus 4, 1. Okay, what do you observe here?
What I observe is that S is on the y-axis.
Yeah.
That means X for S is 0.
Yeah. Any other
And it's
observations?
also on the line PQ, so that S will also be the same y as like P and Q, so it's also
Why do you know it's a horizontal line?
because P and Q are on the same y-axis. Like, sorry, they're on the same, like, they're at the same height. Same.
Okay, P and Q has the same height. You can observe from the above. Because the y coordinates of P equals y coordinates of Q equals 1, and therefore PSQ is a horizontal line. And therefore the y coordinate of S is also 1. So your coordinates of S are 0, 1. So this is regarding the coordinates of S, and you do need to work on a few steps before you complete this question. And then some of you may claim that, okay, can I skip some of these steps, right? you do need to justify why the y coordinate of s is 1. So in a way, I do accept you directly writing that PSQ is a horizontal line because the y coordinates are the same. Without writing this, if you can tell me PSQ is a horizontal line, it's still obvious that you know this already. But to play safe, it's better to write each of these points separately. And I also want to explain why the x coordinate is 0 and the y coordinate is 1. And anyway, with the given information, you find that s is at 0, 1. And then you can work out R and AR, RP, PB accordingly. My question for you though, first of all, may I ask, is there any other way you can justify PQ is a horizontal line? Apart from using the y coordinates, can you tell me PQ is a horizontal line directly? If you, the hint is to go back to pure geometry. If you see that BC is a horizontal line, P is a midpoint, Q is a midpoint, and therefore PQ parallel BC by midpoint form theorem, as your classmates have answered, and therefore you can also justify PQ is a horizontal line this way. So any geometry theorem you learned before may be used in this chapter, including, for example, midpoint theorem. 所有你學過嘅 geometry 冇理由搬咗個 coordinate 就錯㗎嘛，咁所以你任何 geometry 你識嘅嘢你可以搬落嚟。下堂我哋做 centre 嘅時候，我哋就會睇好多呢啲嘢啦。Meanwhile, for this question, has anyone seen the trick? Practice 24? 13 boy, sorry, I didn't catch you. R is minus 2, 3. The coordinates of R is minus 2, 3, so the ratio is 1 to 2 to 3. That. Yeah, I'll leave this for you as practice.